Now let's see the important lens maker equation, which I told you is based on the refraction at a single curved surface. So obviously, in case of this lens maker equation, what we are going to do, we are just taking these two lenses and obviously we are just going to connect them, which will form your lens. Yeah. So if I just consider this part, obviously the ray of your, definitely I can say that. So the object is placed over here. It is going to emit the ray of light, then it will get refracted. Yeah. And I will just show that. So this is now your formation of image over here. Now when I just connect this another one, okay, so what will happen for this, because of that, so it will just get further bent. Yeah, so when it will just came out, so further it will just get bent and final image is forming at this position. If this is I dash, so let's say this one is your I and final image is at distance of V, and this is nothing but at a distance of V dash. So how you are going to write it down for this particular case? So let's say the object is placed at a distance U. Okay, so first case, consider the refraction at a first curved surface. So you have to consider the refraction at a first curved surface. So what you will get? So what is the expression that you will get? That is a refraction at a first curved surface. That is a refraction at a first curved surface. So how you will write it down, that expression? Yeah. So in that case, so simple, I told you that is a mu2 upon V minus mu1 upon U, and again this is mu2 minus mu1 upon R1, and this has to be V dash. So let's say this is the first expression. Okay, now the second one, that is the refraction due to that second surface. So in that case, the image which has been obtained because of the first refraction, now it will act as an object, and finally the image will form at a distance V. So how you can write it down again? So for this particular case also, so this is the final image is in the medium 1 itself. So this is mu1 upon V, then the virtual object, so which will at a medium 2, and this is mu2 upon again which is your V dash. So this one again mu1 minus mu2 upon your R2. So this is how you can write it down. Just now add these two equations. So if you add these two equations, that is a mu1 upon V minus mu1 upon U. Okay, and then again mu2 minus mu1. Okay, you can take common. So this is 1 by R1 minus 1 upon R2. Fine. Just take mu1 also common over here. So this is 1 by V minus 1 by U. So this is mu2 minus mu1. Again this is 1 by R1 minus 1 upon R2. So this is 1 by V minus 1 by U. So mu2 minus mu1 upon mu1, and then 1 by R1 minus 1 upon R2. So 1 upon V minus 1 upon U. Then this one you can write it down, that is a mu2 upon mu1 minus 1 in bracket, that is a 1 by R1 minus 1 by R2. Yeah, and already if we know that, so if U is equals to infinity, so definitely we can say V is equals to focal length. So 1 by F is equals to, again you can write it down, this is as a mu2 1 minus 1, 1 upon R1 minus 1 upon R2. So this is what we will call as a lens maker equation. By just selecting the glasses of different radius of curvature, you can get the different value of your focal length, as well as if the refractive index is also different, then again you can get the different value of your focal length. So this is all about the important ones, that definitely 1 by F, you can say that. So this is mu2 1 minus 1 and 1 upon R1 minus 1 upon R2. Again in that, if you just compare those RHS and LHS, so this one 1 by F is equals to 1 by V minus 1 by U. It is nothing but the lens formula. So this one we can call it as a lens formula, and this one obviously that is a lens maker equation. Yeah, so this is nothing but the lens maker equation. Both the equations are obviously very important, so where we can just calculate either one of the result. Yeah, so just to design that lens, you have to go for that your lens maker equation as well as the lens formula, so you can determine the position of your image. Yeah, so with the help of that, your lens formula over here.